Okay, so we want to determine whether x minus 4 is a factor of this polynomial function, and in order to figure that out, we would first like to find the remainder. Again, we have two methods to find the remainder. One method would be to use the synthetic division, and the other method would be, as we just learned, the remainder theorem. We could simply substitute x equals c in this case is 4, so f evaluated at 4 is, we'll substitute x by 4 and simplify the right hand side, and we get the remainder. And then once we have the remainder, then we are going to go back to our factor theorem, and we're going to say that using the factor theorem, if the remainder is 0, then this is a factor of that polynomial. If remainder is not 0, then this is not a factor. So in this case, let us try to use synthetic division. So how would we set up the synthetic division? We already have this binomial in the nice form, x minus c. C can be easily identified, 4. So we have 4 up here, and then we have to carefully write the coefficients of the polynomial function. In this case, the coefficients would be starting from x to the 4th, so we have 1. And then we have x cubed term missing and x squared term missing. So if those two terms are missing, then that means the coefficients are 0 and 0 for both. So I have 0, 0. Then we have the x term, -3, and then the constant term. Right? So once we have that, then we just follow the steps. Bring this one down. So 4 times 1 is 4. Add these, we get 4. 4 times 4 is 16. 16 plus 0 is still 16. 16 times 4. 16 times 4 is 64. We add these, 64 minus 3 gives us 61. And then finally we have 61 times 4. So 4 times 1 is 4, and 6 times 4 is 24. So 244. And then finally we add these. What do we get? 249. Let us try to write both the quotient as well as the remainder. So what is the quotient in this case? The highest power was 4. That means the quotient has the highest power 3 cubed. So the coefficients are 1. So I have x cubed. We don't have to write 1. Then we have plus 4x squared plus 16x plus 61. So that is our quotient. And what is our remainder? Okay, clearly we can see that the remainder in this example is 249. So how would we write that? How would we write the answer to the original example? So we would say, okay, this should be the proper way to write the answer. Since the remainder is not 0, hence using the, so we are, once we figure out that the remainder is not 0, we just appeal to our factor theorem. So hence using the factor theorem, it implies, so this is the symbol for implies, or we can simply write implies, but in mathematics we usually like to use this symbol implies. This implies that x minus 4, so the remainder is non-zero, which implies that x minus 4 is not a factor of polynomial value. So how did we work this out? We first use synthetic division. We can also use the remainder theorem. We calculated our remainder. As soon as we saw that the remainder is not 0, we know that x minus 4 is not a factor. And how do we formally write it? We just write that since the remainder is not 0, or the remainder is non-zero, or maybe the remainder is 249, hence we rely, or we use the factor theorem, which implies that x minus 4 is not a factor of this. So this is all we are going to do today. In the next class, we are going to use this important theorem, the factor theorem, to solve some more important problems. And the most important problem in this section will be to deal with these polynomial functions and find the zeros and write these polynomial functions as product of linear factors. So there are two things. We want to find the zeros and we want to write them as product of linear factors. And for those, we would need the factor theorem, and we would also talk about a new rational zeros or rational solutions test that will help us to do that. But that would be for the next class. So for today, we will just end the class on this. Okay, thank you.